Hey guys, hope you're having a great day. Over the next 3 videos, we're going to be talking about transformations. Okay, so yesterday we talked about 7 basic parent functions that are all going to be fair game for our transformations, and so today we're hoping to use them. 2 different transformations. It's actually one translation. What we're going to do is we're just going to be moving these graphs that we did yesterday, left, right, up, and down. So first, let's talk about moving them up and down, or a vertical shift. So it says if we have a given function, and a lot of times when I talk about this given function right here, this is going to be my parent function from yesterday. Okay, and I'm wanting to make a new function from it. And so today what we're going to do is we're going to either add k or subtract k outside the function. We'll see what that looks like in just a minute. What we need to know from this is that if we are going to be adding k, if k is going to be positive, then we will actually move up that many units. Whereas if k is going to be negative, or we're subtracting k, the graph will move down that many units. So looking at this graph from yesterday, this is my swoop that we talked about. Swoop was my square root of x. And so if I'm looking at moving the swoop up 2 units, all these points moved up 2 units, I'm just taking the swoop, and then that plus 2 just goes on the outside. Whereas on this green one, I'm taking the original swoop from this blue line right here, and it's moving down 2 units. So I put a minus 2 outside the function, which in this case would be outside the square root. Thermostat control. I know growing up I wasn't ever able to touch the thermostat in my house, and so I still don't mess with it just a whole lot. We kind of just leave it at a normal temperature. But evidently, what this problem says, it says that energy conservation experts estimate that homeowners can save 5 to 10% on winter heating bills by programming their thermostats to be 5 to 10 degrees lower while they sleep. So in the given graph, temperature of a home is given as a function of time, meaning that the temperature is my y-axis, and in the little t is my x-axis time after midnight or 24-hour period. So it wants to know, at what temperature is the thermostat set during daytime hours? Well, during daytime hours is where it's peaking right here. Right? So that should be 72 degrees. And then at night, looks like they go to bed. Hopefully they're asleep down here next to midnight and so forth. That looks to be set at about 65 degrees. So the homeowner is going to reprogram their thermostat to this new function right here. So how does this affect the temperature in the house? Well, I'm looking at it. It might be easier to go ahead and graph the function first. So I see that minus 2 on the end of it. So that means I'm going to take the whole graph, I'm going to move it down 2 units. So instead of being set at 65 overnight, it's going to be set at 63. And then it's going to come up. It's still about 2 degrees less than the line. So pretty much what I do is I try to take that blue line and I moved it down 2 units to the red line. So what that did to my graph was it made it so that it was always 2 degrees cooler with this new program. So how does this affect the temperature? Is now 2 degrees cooler. I don't think we're going to see this a lot with the table, but I do want to introduce this with the table. Okay. If I was to go through and plot all these points, see -3, 2, 3, -5, 1, 2, 3, I think I land right there. -2, 1, 2, 3, -1, -1, 0, 1, 1, 2, 3, 4, 5. Get a nice linear function. Now this time, I'm wanting to actually just make an extra column right here for my g of x. Okay. column for my g of x. Think about what this is doing. I'm taking all of my f of x, or all my y values, and just adding 5 to it. Okay, so that's going to make it so this black point right here comes up 1, 2, 3, 4, 5. So this black point just comes straight up. So all of my y values, I'm just looking at adding 5 to, all the way down. So whenever I create a table for this, my x values are going to stay the same. And after I add 5, after I add 5 to all these, then my table is just going to be x, f of x. And I could come through, and I could plot all the points. I don't think it's asking me to do that, -2, +2. But you would see if I plotted all the points, all of these black points came straight up 5 units. I want to talk about horizontal shifts, and then that'll be it for today. I'm going to save all of the other transformations for tomorrow. So this time, notice I'm going to switch letters. I'm going to let it be an h inside the function. Okay? And so again, we're going to be able to add or subtract the h, but the big thing here is that this time I'm inside the function. Okay? My f of x is still one of my parent functions we talked about yesterday. But one thing we're going to have to notice over the next 3 days is that every time something is inside the function, it's backwards. Let's go back to last week when we talked about circles. If I had x plus 3 squared, I'll write this down. X plus 3 squared and y plus 3 squared, whenever equals some r squared, doesn't matter. Whenever I went through and plotted this, my center was at -3, -3, right? Down here. Just like this was backwards when I pulled it out, it's always going to be backwards inside the function. Meaning that if this h right here does take the bottom row, it becomes negative. You would think if I had negative, I would go to the left. Instead, it's going to go to the right. Okay? And then if h is positive, I would think I would be supposed to be going to the right. But what? I have to go to the left instead. So let's take a look at this graph down here. This blue graph right here is my cube root function, right? Cube root, the snake taking a nap on the plane, maybe? I don't know. And so to get to this red function, okay, this red snake, it went to the left. So I would think if it goes to the left, I should subtract 1, but it's opposite. So it's going to be x plus 1 because it's opposite. And notice that it's inside the function. It's inside that cube root. That makes it so it's inside. If I was moving it up or down, the cube root wouldn't go over that 1. Here's some more examples of that. Before we get going on it, let's go back to the temperature problem. We've already done A and B. Sorry this is so small. It was as big as I could make it with making it look decent on here. It says the homeowner is going to reprogram it so that it follows this function now. Oh, I see the +1, and I see that it's in parentheses. It's inside the function. Then it's opposite. So anytime I see the +1, I think move right, but it's opposite. So everything's going to move left 1. So I'm going to take this whole blue line right here. I'm going to move it to the left 1. Kept all the same y values. Just went to the left. Maybe I shouldn't have done that far. Oops. I erased too much. Good job. It's like right there. So I moved everything back 1 hour. I pretty much took this blue line, I moved it to the red line by moving it to the left 1. So what does that do to the temperature in the house? Well, got to make it so the temperature is not going to change. It's still going to be hitting the same 72 degrees in the day and 65 degrees at night. But it's going to do that an hour earlier now. So we could say temperature changes will now be an hour earlier. Maybe since it gets dark earlier in the winter, you want to go to bed earlier. That's how this person would reprogram it. Okay. Okay, let's try a table. It's going to be a little bit different on the table than it was the last time. Again, I can go through and plot all these points. I don't think I'm going to. -3, -13. It's like 4 cents off the graph. It's all in there. -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. You can definitely go through and plot all these if you wanted to. 0, -1, right here. I'm going to stop or else I'm going to end up plotting them all. But this time notice that I have g of x plus 6. X plus 6. Remember, it's opposite. It's not plus 6. It's inside the function, so I'm thinking horizontal. I'm going to go back to the left 6. Now let's think about what is actually going to go to the left 6. These points are going to the left 6. So this red point, 1, 2, 3, 4, 5, 6, I'm moving it all the way back to right here. So its y value didn't change. So the g of x is still the same. What's going to change is the x value when I bring it over. This g of x is still the same, negative 13, negative 9, negative 5, negative 1, 3, and 7. It's the same as the same height. But my x values, since they went to the left 6, I'm going to subtract 6 from all these, all the way down. So that would give me a negative 9, and then a negative 8, negative 7, negative 6, negative 5, negative 4, all the way down. So this would be my new table. And lastly, I just want to make some up. I'm going to make some up for you to try. We'll do one together, then you'll try one. We'll call that good. Okay. Find a formula for the function. So I'm going to draw something on the board, and then you're going to have to use your parent functions from yesterday and figure out what it looks like. Like I said, we'll do the first one together. Okay. Let's see. I'm going to do this one. Yeah, I might throw you off. I've got a U sitting down here. Okay. Now, first of all, I see that it's a U. Okay. So from yesterday, U is going to be my squaring term. Now, I know I wrote that kind of weird. I left a lot of space because I might put something inside, might put something outside. It's going to work fine for what we're writing by hand right here. Now, the U did not move left or right, so I don't have to do anything inside. Instead, what it did was it came down 1, 2, 3 units. So if it comes down 3 units, that was outside the function, and everything outside the function makes sense. So my function is just going to be x squared minus 3. That would give me this graph. Think you're a hot shot now, maybe, on this. Let me give you this one. See what you would put down on this one. Then we'll so go ahead and pause it, and then come back and see if you get the right answer. I got x plus 3 cubed. I had to use parentheses on this one to put it inside the function. And notice that my cube is way out here still, so that this 3 is on the inside. Good. All right. I got you stumped. This next one's going to stump you. Let's do this one more time, and then see if you get it. All right, I'm going to do this right here. Draw this guy. Right, go ahead and hit pause. Write your answer down, and then come back. Did you get it right? I hope you did. Okay. What if I was to ask it the other way? What if I was to give you the function and you have to sketch it? Ooh. Let's see. What's one I haven't done a lot of? Oh yeah. Let's done this one. Let's do. There we go. Okay. Hit pause and graph that one. All right, yeah, I just moved it to the right for its absolute value. Value has a V. I'm going to graph my V. And I show my work on this. I like to show my work on the graph. So this first dotted line that I did right here, that was just my basic parent function. That's just to make sure I have that part of it down right. But notice I made it a dotted line that says, hey, Mr. Lovely, I don't want that V graded. I'm going to move this V around. In this case, I moved it to the right 4, and whenever I do that, I'm going to make it so it's solid V. So that means you want this one graded. All right. So whichever one's solid on your graph, I will be grading that one. Okay. I think that's good. So let's